Hi, my name is Jeremy. I'm from G10C. My friend calls me DJ, short name for Darren Jeremy. Today I'll be talking about this Arduino board and how to use it. First of all, I want you to look at these numbers. These numbers, I'll be talking about the numbers from pins 2 until 13. We will call them the digital pins for now. As you can see from here, these are called the analog pins. These pins ranges from A0 to A5. Now these digital pins, they give out power, 5 volts to be specific. These are where we'll be putting our components and wires, such as like LEDs and stuffs. As you can see, there are squiggly numbers like 11, 10, 9, 6, 5, and 3. Now what do these pins mean? We'll call them pulse width modulation, short for PWM. We will these pins will give out values from 0 to 255. This could be useful for adjusting voltage on your LEDs. So let's talk about the analog pins. The analog pins are the one that ranges from A0 to A5. What do these pins do? These pins gives you values from 0 to 1023. This could be useful for gathering data on the Arduino and could be useful for sensors. And now, as you can see, there's the sign called GND. GND is short for ground. So what ground means, it gives you 0 voltage. And this 5 volts is actually a very appropriate name for its sign because it literally gives you 5 volts. So this is called a solderless breadboard. The solderless breadboard is where we'll be putting our wires and components, because obviously we're not going to put everything in the Arduino board. It will be completely messy. So let me show you how this works. These rows are electrically connected from these rows and these rows. As you can see, there's like a line dividing these two rows. That means they're not electrically connected. See here, there's like a plus and negative sign over here. Now what do these mean? This is basically where we will be putting our wires from 5 volts goes to the plus sign, and the ground pin goes to this row. Now these these rows are not electrically connected like the ones we saw in here. These are electrically connected this way instead of this way. So you can see here, I have a red LED. In this red LED, you can see two legs. One leg is longer than the other, and one leg is shorter than the other. What do these mean? Well, it's simple. The long leg is called an anode. The anode gives you 5 volts, and you'll be putting your resistor here. The anode will be connected to a digital pin. If you remember, the digital pins are the one from 2 to 13. Now, the short leg of the LED is called a cathode. The cathode is where you'll be putting your is where it will be connected to the ground pin. So I'm going to be connecting this LED to the Arduino. First step, this is the long leg and this is the short leg. This is the anode, this is the cathode. Right, so I'll be connecting it to the breadboard now. Anode here, cathode here. Now this anode, I'm going to connect a resistor to it. Make sure you connect the resistor to the LED. If you do not do that, your LED will burn out. You'll cause a fire. We don't want that. Remember, these are electrically connected. So I'll be putting the resistor in this part of the breadboard. It's hard sometimes, so it takes time. Alright. Remember, where does the anode go? It goes to the digital pins. So we'll be connecting it to the digital pins. It's a bit messy, but it's fine. Right, remember what are the digital pins? 0 to 13. Choose any of these pins. Doesn't matter. For now, I think I'll connect it to pin 8. And now, the cathode. The cathode goes to the ground pin on the Arduino. So we'll connect it to there real quick. The ground pin is over here, as you can see. So I'll be connecting this Arduino board to the laptop. In order to do that, we must connect a USB cable from the Arduino board to the laptop. In order to do that, we use the USB cable provided by the Arduino kit. If they did not give you this, then ask for a refund. Right. So we'll be connecting the USB cable in this part of the Arduino board. Simply connect it like this. As you can see here, we have another point of the USB cable. In here, we simply connect it to the side of this laptop. As you can see in the Arduino board, you get some lights. It means what you've done is successful. That's a good sign. And now we're going to open the Arduino IDE. That's where we're going to do our programming. This is the Arduino IDE. This will be writing our program. As you can see here in the Arduino IDE, we have two things that says void setup and void loop. What do these mean? The void setup is the code that will run once. I repeat, this code will only run once. The void loop is the code that will run forever and ever until someone eventually unplugs the USB cable from the laptop to the Arduino. Right, first of all, I'm going to be declaring a variable. In order to do that, we're going to type something called int. Int is short for integer. And after you do that, we're going to give it a name. So what we're going to give it a name? What name are we going to give it? Let's say LED pin. Now, what are we going to put in that variable? We're going to put the number that we connected our LED to. What was that pin that we connected to again? Do you remember? That's pin 8. So we're going to put 8 in there. Note that we're going to have to put a semicolon at the end of each code. If you don't put a semicolon at each at each line of code, it's going to throw in an error. No matter how small the error is, it's still going to throw in the error for the rest of the code. Now, for the void setup, we're going to type in a command called pin mode. You see that it went orange. It means that Arduino recognizes this command. Now, in pin mode, it's gonna take two arguments. What pin is your component connected to, and is it gonna be an input or an output? So let's type in our variable first in this command, in this pin mode. What was it called again? Pin mode, LED pin. And now we're gonna put a comma, and we're gonna put in an output. Why an output, you ask? Why not an input instead? Well, we're going to be giving out voltage to this LED pin. It means it has to be an output. If you're going to measure something, it's going to be an input. So, summarize. The void setup is where we're going to put our pin modes in. And we declared a variable called LED pin, which is connected to pin 8. The void loop. The void loop is where the code will be running over and over again until someone eventually unplugs the cable from the laptop to the Arduino. So we're gonna type in a command called digital write. Right, see, it's orange, which means what? The Arduino recognizes this command. Now digital write takes two arguments. What pin is your component connected in? In this case, ours is connected to the pin 8 on the Arduino pin. So I'm going to type in my variable called LED pin, which is connected to pin 8. And comma, is it high or low? High means it gives 5 voltage. Low means it... Right, after typing this line of codes, I'm going to upload the program to the Arduino. So just do that. Sorry about that. Right. It's, it's gonna take a while. Right. It's done uploading. And as you can see, the LED has turned on. And as you can see, it's gonna do this forever and ever until it runs out of power, or I unplug the USB cable from the laptop to the Arduino, as I said earlier. Unplugged. See, it's off. And if I plug it again, it will turn on. Alright. Now, what if I wanted to make the LED blink on and off every 1 second? Here, I'm gonna write in a command called delay. Now, delay takes the units in milliseconds, not seconds. Milliseconds. So 1 millisecond equals 1 second. I wanted to turn it on and off every 1 second. So we got the LED pin high on, and we got the delay 1 second. What do you want to do after that? Well, we wanted to turn off for every 1 second. So try to guess what's the command. Digital right LED pin high or low? Low, because we wanted to give 0 volts to the LED, which will turn off. And now after that, we will put another delay for 1000 milliseconds, which is 1 second. And now to prove this works, I'll try to upload the code to the Arduino again. Hope it works. As you can see, it's now blinking for every 1 second. I want to note that you can name your variable anything you want. You could name it your cat's name, you could name it your dog's name, you could even name it your name. But I would recommend giving it a specific name. You might name it your cat's name today, and then the next day you visit your code, you go back to your code and you see the word cat in here. Let's say the cat's name is Darren. Like today you'll know that Darren is connected to pin 8. That's an LED pin. And then the next day you might come back and not know what the heck you just wrote. So I expect you to, I recommend you to write it, give it a specific name like LED pin. See, that's specific. But we're gonna do something, we're gonna write something that's called a comment. A comment is basically to take notes for everything you do in the IDE. So you could write anything in the comment, like this LED is connected to pin 8. Now the next time you visit your code, you could see that this comment and know what you wrote and what you did. And the reason why I declared a variable in here, I connected it to pin 8 instead of using the number 8 in here. What if you had 10 pin modes and you wanted to change all of them to 8 or 9 or 10? That will take a very long time. If you have 10 pin modes, you're gonna have to change the pin mode like every 10 times. Like you're gonna change this pin to pin 9, and then you have 10 pin modes. You have to change all those pin modes from 8 to 9 like 10 times. But then if you declare a variable, you could just simply change it to pin 9. It's that simple. Look, also this. You could also write your number of the pins you're connected to in the digital right by just changing this number by 9. What if you wrote the number 9 instead of the variable 9, the variable LED pin again? See how frustrating it will take? Remember our LED pin was connected to pin 8? What if I wanted to connect it to pin 9? I would take this wire and change it to pin 9. So I changed all these pin modes from 8 to 9, which is quite very long. It took quite a very long time. That is why I declared the variable LED pin 9. So I could just change it from 8 to 9. To prove this works, I will upload the code again. See? It works.